I now call to order. This is the lecture portion of the Society's 2504th meeting in what is now the 153rd year since its founding on March 13th, 1871. Good evening, everyone. Good evening, Larry. My name is Larry Milstein, as some of you seem to know. I'm the president of PSW, one of the oldest scientific societies of Washington, D.C., committed to providing a forum to further scientific understanding and inquiry. Welcome to our members, guests, and friends to tonight's PSW lecture by Jason Eckberg. The Society is grateful to PSW Full Year Series sponsors, PSW member Mike Helton and Helton Associates LLC for their support. Thank you very much, Mike. And to the sponsor of tonight's lecture, a PSW member who is something of a shrinking violet, who wishes to remain anonymous, but to whom we are nonetheless grateful. So let's thank our anonymous supporter. I am pleased to note that the following new members have been admitted to the Society: Christopher Angelo Buenaventura, an engineer with the federal government, interested in energy technology and machine learning, who learned a PSW from searching the web. Kevin Stemp, an attorney with the SEC, interested in, among other things, AI, national security, and defense, who learned a PSW from an email. And tonight's speaker, Jason Eckberg, who learned a PSW from the invitation to speak here tonight, and from corresponding secretary and executive director and person who does everything and makes everything happen, Robin Taylor. Whose interest will be clear in some small part, no doubt, from tonight's lecture. If you're interested in membership, you can access a membership application on the PSW website by clicking the blue join button on the upper right-hand corner of the home page and following the prompts. And if you are here in the Powell Auditorium and you haven't joined yet, by all means proceed forthwith to a table in the back of the room where you'll find a card, business card-like thing that has QR codes that will take you directly to the membership application, which you can fill out, pay your dues, and become a member. All members are entitled to a signed copy of Volume 1 of the Bulletin of the Philosophical Society of Washington, aka PSW. And if you so choose to purchase and wear the ribbon of the Society. All members are invited to receptions and dinners with the speaker preceding each lecture. If you're a new member and you have not received your signed copy of the bulletin, please come see me after the meeting. Recording Secretary Scott Matthews will now present the minutes of the 2503rd, the minutes of the lecture. The minutes of the 2503rd meeting and the lecture by Alexandra Gade on the science of rare isotopes. Scott, the stage is yours.
On October 18th, 2024, members of the Society and guests joined the speaker for a reception and dinner at 5:45 p.m. in the members' dining room at the Cosmos Club. Thereafter, they joined other attendees in the Powell Auditorium for the lecture proceedings. In the Powell Auditorium of the Cosmos Club in Washington, D.C., President Larry Milstein called the 2503rd meeting of the Society to order at 8:07 p.m. Eastern Time. He began by welcoming attendees, thanking sponsors for their support, and announcing new members. Scott Matthews then read the minutes of the previous meeting, which included the lecture by Mark Okrand titled Klingon and Other Constructed Languages in the Real World. The minutes were approved as read. President Milstein then introduced the speaker for the evening, Alexandra Gade of the Michigan State University Facility for Rare Isotope Beams. Her lecture was titled The Science of Rare Isotopes. The speaker began by defining rare isotopes as those not found on Earth. She indicated that there are fewer than 300 stable isotopes, but that there may be as many as 7,000 possible isotopes. She discussed the process by which unstable nuclei decay to stable nuclei, alpha decay, beta decay, gamma emission, positron emission, electron capture, and spontaneous fission. She then introduced the nuclear chart, often called the table of the nuclides, which shows a graphical representation of all known nuclides plotted with the neutron number on the x-axis and the proton number on the y-axis. Using the table of the nuclides, Gade described how an unstable nucleus can move towards regions of greater stability through the various decay processes. She described the proton drip line and the neutron drip line, terms arising from the nuclear liquid drop model, as the limit of the number of protons or neutrons that can be bound to a nucleus. She indicated that the proton drip line, being governed by Coulomb repulsion, was well defined, but that the neutron drip line was largely unknown. Gade then discussed the formation of rare isotopes on Earth using the techniques of light particle reactions, neutron reactions, fusion, and fragmentation spallation. She went on to discuss the formation of rare isotopes in stellar environments, such as supernovae and neutron star mergers. She described the competition between neutron capture, pushing nuclei towards the drip line, and beta decay, pushing nuclei back towards stability. Gade then discussed the techniques for producing rare isotopes in the laboratory using particle beams. A stable nucleus is accelerated to about half the speed of light and smashed into a target nucleus. The fragments of this collision are, quote, fished out and guided to experimental stations, unquote. She described how magnetic fields are used to separate or filter the various isotopes by charge-to-mass ratio. She showed a brief graphical video demonstrating each step in this process. Gade then described the discovery of 5 new isotopes at her facility, called FRIB, Facility for Rare Isotope Beams, which included heavy isotopes of thulium, ytterbium, and lutetium. This involved accelerating stable platinum-198 nuclei on various target nuclei and separating and identifying the fragments to confirm the presence of these 5 previously unobserved nuclei. She claimed that these isotopes are formed in neutron star mergers and that understanding the properties of these isotopes is therefore critical to understanding nucleosynthesis of heavy elements. The speaker then discussed the formation of new elements, particularly the super-heavy elements. Although the FRIB beamline is not capable of producing such elements, she described the processes for synthesis, identification, and confirmation, indicating that many of the recently confirmed new elements have been synthesized in Russia and Japan. These super-heavy elements decay by alpha decay. Gade described how researchers follow the alpha decay chain in reverse, starting from a known daughter nucleus, counting the alpha decays back up to the parent nucleus in order to identify the new element. She said that it often takes years or even decades to officially recognize a new element, as it must be produced in multiple facilities by multiple techniques before it is accepted. Gade said that very recently, Lawrence Berkeley Lab showed that super-heavy elements can be produced using a titanium beam, and that the U.S. is now back in the race to produce new super-heavy elements. Gade then discussed the motivation for studying rare isotopes, including a variety of applications. She discussed how the nuclear physics of rare isotopes enables more accurate modeling of stellar events like neutron star mergers. She discussed medical isotopes used for both diagnostic and therapeutic applications. She showed examples of rare isotopes being used to image real-time biological processes and to destroy cancer tumors. She discussed the role of rare isotopes in the design and modeling of nuclear batteries, particularly for long-duration space probes, and the role of rare isotopes in modeling nuclear weapons in the absence of nuclear testing. She mentioned the use of rare isotopes for studying radiation-hardened electronics for space applications. The speaker concluded her talk by saying that rare isotopes play an important role in fundamental physics and allow a variety of technological applications from biology to microelectronics. The lecture was followed by a question and answer session. A member asked about the use of rare isotopes to enhance our understanding of the nuclear force. Gade indicated that this was exactly the point of her research. She said she worked closely with theoreticians to validate and modify nuclear models, including models of the nuclear force. A member asked about one of Gade's charts showing the rate of discovery of new isotopes as a function of time, citing the fact that there was a significant spike around 2010 or 2011. Gade responded that during that period of time, a new facility for studying rare isotopes came online in Japan. This new facility discovered more than 100 new isotopes in its first year of operation. A member on the live stream asked if rare isotopes are responsible for a significant fraction of the radiation that we see in the universe. Gade responded that while X-ray bursts are the most frequent explosions in the universe, the vast majority of the observed radiation is not coming directly from rare isotopes. However, a significant fraction of the total power radiated is due to rare isotopes. After the question and answer period, President Milstein thanked the speaker and presented her with a PSW rosette, a signed copy of the announcement of her talk, and a signed copy of Volume 1 of the PSW Bulletin. He then announced speakers of upcoming lectures, made a number of housekeeping announcements, and invited guests to join the Society. He adjourned the 2503rd meeting of the Society at 10:03 p.m. Eastern Time. Temperature in Washington, D.C., 14.4 Celsius. Weather, fair. Audience in the Powell Auditorium, 36. Viewers on the live stream, 28, for a total of 64 viewers. Views of the video in the first 2 weeks, 506. Respectfully submitted, Scott Matthews, Recording Secretary.
Thank you, Scott. Are there any comments or corrections to the minutes? Well, I have one. To be technically correct, we're making a little change, which is that I don't gavel the meeting to order. I gavel the lecture portion of the meeting to order, because the meeting really begins with the reception. Okay?
I will make that change.
Thank you. And with that change, do I have a motion to accept the minutes as read? Second? All members in favor? All opposed? Minutes are accepted as read and will be posted to the website. If you're online and you have some urgent comment or correction, please email it to corresponding sec at pswscience.org. We'll take it into consideration and make any necessary corrections. And with that, let's turn to tonight's lecture by Jason Eckberg on Ukraine conflict, Uncrewed, Ubiquitous, Unprecedented, Modern Technology Applied to War. Jason is a colonel in the United States Air Force and is the division chief of the Persistent, Penetrating, Multi-Role, Remotely Piloted Aircraft Division of the Operations Directorate at United States Air Force Headquarters. The division oversees policy, operations, training, and manpower for all remotely piloted aircraft in the U.S. Air Force. Jason recently served with the Security Assistance Group Ukraine as the officer in charge of the advisory contingent in Kyiv. Jason received his commission from the Reserve Officer Training Corps detachment at Carnegie Mellon University. He served as an RC-135 electronic warfare officer, instructor, evaluator electronic warfare officer, and combat crew commander. He is commanded at the squadron, group, and vice wing levels. And in addition to these deployments, he's a master navigator with over 2,000 hours and over 20 unique aircraft. He earned a BS in chemistry at Carnegie Mellon University, an MS in administration at Central Michigan University, and MS in cyber warfare at the Air Force Institute of Technology. He was also a military fellow in security studies at MIT, and he is a graduate of the Squadron Officer School, Maxwell Air Force Base, and the Air Force Test Pilot School Experimental Flight Test Navigator and Air Command and Staff College, Maxwell Air Force Base. He tells me he's not flying anymore, so I'm not going to get a chance to try and hitch a ride with him. But we're looking forward to his talk. As usual, questions will be fielded in the Q&A session after the lecture. So without further ado, Jason, the stage is yours.
Well, thank you very much, Larry. I appreciate it. Thank you, Robin. 2 weeks ago, when Robin and Larry asked me if I would be interested in speaking. I said, I would love to speak. Mary immediately, my wife back in the thing, immediately shook her head and said, yeah, we know you love to speak. And so we'll look forward to that. I accepted the invitation, and I'm honored to be here in front of this august institution, this august body. It is kind of intimidating to be looking in front of you, and to all the folks that are online to be listening to this. I hope that you find some nuggets of good information as we talk about some of the experiences that I've had in observing uncrewed systems in combat over the course of the last 7 months as I was part of the Ukraine advisory contingent for the U.S. military underneath European Command. So with that, I will start with my proclivity towards alliteration. Uncrewed, ubiquitous, and unprecedented. All words that in the experiences over the last 7 months I've come to accept as a description of the conflict between Russia and Ukraine. Throughout this time that I spent in that advising effort, it became clear that we are witness to a natural experiment, as political scientists would describe it, in the activities of two very large militaries facing each other every single day. As we tackle the ramifications of the challenges of two nation states engaged in large-scale combat, it is absolutely essential we analyze and accept this opportunity to inform and improve approaches, organizations, and operational strategies for our collective defense. Now, that was a remarkably antiseptic way to describe a violent conflict going on right now. Throughout the course of the conversation tonight, we will dissect using objectives and technical terms to describe an environment and activities and actors of this situation. But I must state clearly and unequivocally that in no way do I wish to minimize or in any other ways deny the moral and emotional toll that this war has had on the respective combatants, in particular the people of Ukraine, a sovereign nation invaded by their neighbor Russia over the course of their very existence. Ukraine and Ukrainians are fighting for their lives. And while it is useful and fascinating academic exercise to analyze the how and the what of modern combat, real people are affected and affected in real ways. And we won't lose sight of that fact. Thank you again for allowing me to speak this evening, and with this, we will move forward. Now, in the finest traditions of my service, it is appropriate to provide an overview of what I will discuss. I was just told, as Larry mentioned, I'm a graduate of the proud institution of Squadron Officers School, where they taught you, tell them what they told, tell them what you're going to tell them what you told them. That's the perfect answer for a way to go forward. To that end, the slides are intended to be a stand for discussion, and while you will get the gist of this lecture from them in a standalone fashion, a truly important piece will be this conversation that we engage in tonight. The thoughts presented are my own. However, they are founded in both direct and indirect observations, and sprinkled in them, you will hear reflections of military innovation luminaries such as Barry Posen, who I had the opportunity to study under at MIT a few years ago, as well as the work of Stephen Rosen, who has established a standard in analysis of military innovation. Further, I leverage heavily the wide range of open source work, especially the Institute of Study of War, Ukraine Conflict Project, Ukrainian sources through ualive.ua, and individuals and groups who are engaged in the development of equipment and tactics. And the final conclusions are the ones I draw from this experience and are informed by many sources, but the perception that I would represent others' thoughts of my own would not be intentional. So reflecting over the conflict in the last 2 weeks, and as I developed this presentation to meet the requirements of PSW Science Organization, linking technology and innovation on the modern battlefield spawns a wide range of topics. And as you know, technology is broad. While the battlefield in Ukraine is beset with uncrewed system, the use and abuse of technology between combatants goes across domains and disciplines. Elmer Leonard, I think, coined the phrase, hyperbole is the fuel behind motivation. Well, in today's information environment, hyperbole appears to be the standard. The effective use of open source social media and rapidly disseminated, selectively highlighted data will feed impressions and perceptions that rapidly become a reality and can cause real effects against military and societal forces. The use of data to support information operations is not a new phenomenon. Employing diversion tactics to fix forces in place is standard military tactic. Just as U.S. Grant in his use of Benjamin Grierson's raid in Mississippi in the spring of 1863 to divide Pemberton's forces at Vicksburg, or look at the use of Patton's First Army during 1944 to satisfy the cognitive bias of the Nazi forces to remain at Calais. What's different here is technology has enabled scaling of the use of data to support an information campaign that accelerates the intent and impact of seemingly insignificant apps in another time would have been overlooked and ignored. Using stochastic terror methods, thank you, Pete Singer, the actors with their resources of nation states have been able to amplify messaging and events in such a manner to distort the reality of both endogenous and exogenous populations. In fact, it's for this very reason that even speaking tonight gives me some pause in that I may say or do something on stage that could be amplified or taken out of context, fulfill a distortion of reality for millions. On that note, it's not overly concerning as the very tone of my voice has been known to put even the most energetic of souls into somnambulant states. So this going viral is probably of little likelihood, but who knows? 500 views in the last 2 weeks for your previous speaker, which was a very impressive one. So the use of technology in the information sphere has proven effective in turning world opinion and actions in specific directions. Russia has proven particularly adept at employing massive bot farms supported by lax content curation on a multitude of social media channels. The information war going on via Telegram between Russia and Ukraine is a right place to look for what is effective in forming national and international perceptions. It is also demonstrative of the tactical battlefield that is the information environment and the direct relation to the visceral physical environment where people become casualties. The use of uncrewed systems, as we will talk about, as we will continue to talk about, to provide images of a battlefield, utilize this ripe and dangerous information environment in order to amplify successes or defeats and provide the international community with judgments by which they will make international decisions that either resource or retain resources from being able to support a combatant on this battlefield. So first and foremost, hyperbole becomes reality in the information environment engaged in, and while I've done my best to extract physical and technical reality from that environment through observation and analytics, there may be places things get complicated. In terms of complications, the reality of information environment does highlight the technological ubiquity of constant battlefield surveillance. In that light, and with the ability for military formations to observe and orient with accelerated precision the trivariant relationship between efficiency, effectiveness, and economy are important to identify. With such a ubiquity of information available to military formations, the necessity to flow battlespace data and information with efficiency and economy ensure that the pipes that drive the data that's coming from the field to ensuring that the just right information is provided to decision makers will drive effectiveness of solutions available. Spoken another way, the demands of the modern battlefield require judicious parsimony to ensure information is provided to decision makers accelerating kill chains. I think if you've read Chris Brose's book, you'll see the importance of accelerating those kill chains as rapidly as possible. Or to look at compressing OODA loops. Those of you that are familiar with John Boyd, observe, orient, decide, and act. A standard model that we've become to accept as to how do you develop the right actions in order to overcome the challenges of an adversary. Or you use the reconnaissance strike complexes that are extant on the battlefield. What I'm referring to here are the ability for that information to be fed back to the right decision makers at the right echelon in order to make decisions that then will achieve some level of eminence on the battlefield. Technology in the form of uncrewed systems at the center of this discussion around all the battlefields presented today. The effectiveness of these challenges are apparent when trying to offset asymmetric advantage or disadvantage. Russia and Ukraine are mismatched in terms of organic resources, firepower, and sanctuary. Neutralizing asymmetric advantage is the necessary condition to not lose in a competition where forces are matched in terms of tactics and technology. Asymmetry conditions will absolutely lead to military innovation and adaptation under fire. The thing that we have to understand in this entire fight is that if one side does not have an advantage in some place, they have to find ways in order to find that advantage. Uncrewed systems have been the demonstrable effect of that attempt to achieve an advantage on an asymmetric battlefield. Typifying those innovations, the alliterative advance of my 3 U's comes directly into play. Uncrewed, ubiquitous, and unprecedented. So what does a modern battlefield look like? I perceive that we have 3 physical domains in which the battles are being fought. You have the Eastern Front, which extends from Kharkiv here in the north to Kherson and into Russian-occupied Ukraine. After the Ukraine successfully and bravely fought back after the 2022 invasion, the battlefield has stagnated in this particular location. The oblasts of Kherson, Zaporizhia, Donetsk, Luhansk, Starbilsk are all occupied by Russian forces, and a first echelon of combat is established there. The second physical domain are attacks on sovereignty, something I've cleverly come up with. Yes, I pat myself on the back for being clever a lot of times. The attacks on sovereignty are typified by the daily violation of the air space of Ukraine by the use of Russian uncrewed systems in the form of Shahed drones, in the form of Orlan 10 ISR systems, the form of Zala Lancet UAVs, and in the form of ballistic missiles and cruise missiles launched from sanctuary stations in Russia. The other part, and this is one which, again, as I continue to unpack my experiences and watching this unfold, are securing the Black Sea and the utilization and the ability of Ukraine to ensure that grain corridors that are feeding the economy of Ukraine and are feeding the rest of the world remain open, and that Ukraine uses what tools and resources it has in order to evict Russian forces from the Crimean Peninsula and from the Black Sea. And finally, the opening of the Kursk offensive back about 2 months ago by Ukraine clearly indicates the necessary condition to open more challenging decisions for Russia as it continues its onslaught. And it'll be important for us to think about that from the perspective of what advantages, what asymmetric advantages that those uncrewed systems brought to be able to bear in that Kursk offensive. So defense in the east. This is the most developed battlefield in Ukraine combat zone. 1,200 kilometers of front line, constant pressure from Russia to try to continue to push into Ukraine. Russia has committed to positional warfare that maximizes their advantage in personnel, firepower, and sanctuary. In personnel, they have a massive military, 500,000 to 1 million folks in uniform that are able to basically be fed into constant pressure across the entire front. Firepower advantages of 10 to 1 to 12 to 1 in long-range artillery. And sanctuary in the sense that they are able to garner forces from within Russia and into those particular Ukraine in order to continue to feed this fight. In the last year, They've put constant pressure on the Ukrainians. In April, they opened an offensive in Kharkiv, which you've... Use this. There we go. Up here. They opened an offensive against Kharkiv with a perception of weaknesses in Ukrainian defenses. However, in response, Ukraine has established a long first echelon and second echelon defensive fortifications all the way along this particular front. Now, the going heuristic, since Germany analyzed Napoleon and wrote his treatise on warfare, is to sustain an offensive aggressor must have an advantage of at least 3-1 in forces. The facts are Russia regularly maintains a higher advantage to key objective points across that front. Key locations such as Krinky in the south, Donetsk and Pokrovsk in the center, and Chasiv Yar and Luhansk have been shown particular attention by Russian forces. In those regions, manpower and firepower advantages exceed the 3-1 heuristic on a regular basis. Through the use of smart terrain selection, unmanned aerial systems, and the tactical awareness that comes from employing those, Ukraine has succeeded in delaying the advances of Russian forces. Russia has used its advantages to grind away at Ukrainian forces, and through the use of the same, specifically in using uncrewed aerial systems in the ISR role, as well as loitering and lethal munitions, have been able to exploit gaps at critical times. Even a military as ponderous and overburdened with the decision fatigue as the Russians are, this ubiquitous surveillance complex that they have been able to exploit gaps and seams where they found it. One that we had to watch on a regular basis, one that we had to watch this summer was the advance towards Pokrovsk right here in the center of the front. It developed out of the ubiquitous surveillance and of gaps in the lines that were inadvertently positioned there. And they were able to use that, a force such as Russia that is not necessarily known for its ability to utilize decision advantage as rapidly as other missions, was able to use that in order to exploit the gap, be able to bring higher firepower and people to bear in order to exploit in a gap and to be able to push forces back towards Pokrovsk. In addition to that location, removal of Ukrainian forces here in the south. I will say that the Ukrainian forces have been able to, they held out for a long period of time on the south side of the Dnieper River, so a stronghold in the Krinky area. But due to overwhelming firepower and continual pressure, they finally had to be moved back to the north side of the bank. But those small units that were on the south side of the Dnieper River were sustained through the use of uncrewed systems such as delivery drones that were able to provide materiel and ammunition to forces that were on that side. Remote controlled boats that were able to come across the river in order to provide them. Uncrewed systems being able to use non-lethal support to the two forces that are engaged in combat. And then in the north, again, exploited with the use of that ubiquitous battlefield surveillance, the Russians were able to push all the way to the Oskol River. In recent time, you've been able to see that particular advance be made. Now, in that, Ukraine has made Russia paid for every single advance that they've made through a combination of first-person viewer drones, the effective fire control of artillery, and then select loitering munitions that were able to be able to deny and work and be able to work to provide advantage in a place where you didn't think that advantage could be applied. Now, as I start to talk about ubiquitous, I will point you to back here. I will point you to this number right here. Thousands of UASs, of uncrewed aerial systems in the form of FPVs, ISR drones, one-way attack drones, and lethal drones are being utilized daily on this front. To put it in perspective, the United States Air Force flies MQ-9s in during daily operations in the tens of numbers. So there is an order of magnitude difference in uncrewed systems that are being employed on this battlefield than we are used to doing. That's probably an overly simplistic, overly simplistic metaphor that I've made with it, but it is, but it does show the volume and the unprecedented volume of uncrewed systems that are being used daily. In addition to that, the cost of each of those individual drones is so low that they're able to make the supply work for being able to go after the Russians. And then finally, we go back to that ubiquitous and unprecedented character, the innovation of fire and maneuver support that comes from being able to have that kind of constant surveillance is available. All right. Moving on to attacks on sovereignty. So what you'll see on this slide show a certain amount of innovation that is associated with... I'm not doing well with the remote. I apologize. This is a screenshot from a civilian application that you can download from the the Apple Store, or you can download from Google Play. But it connects directly to the air operations centers that the Ukrainian Air Force mans and equips to provide salient warning 24 hours a day, 7 days a week, to allow for individuals across the country of Ukraine to be able to find shelter when they are attacked through the use of the Shahed 136 drones, surface-to-surface missiles that are utilized closer to the front, but also can reach into as far into Ukraine as possible, and then also the utilization of what these are UMPKs, which are cheap glided bombs that Russia has been able to produce at scale and in mass in order to bring effects to bear. So, walking down what is in this particular slide, when I talk about the air war being noticeably one-sided, Ukraine does not have air superiority over its nation. What they have been able to do is they have been able to mitigate the layered effects of uncrewed, unmanned systems like one-way attack drones, the Shaheds, cruise missiles, and ballistic missiles through the use of equipment in the terms of long-range surface-to-air missile system like donated Patriot systems, utilize systems that are former Soviet, that they had in their inventory, combined with Western munitions to be able to innovate and provide munitions to be able to increase the capacity at mid-ranges in order to defend in there. And then finally, utilize what is probably one of the more interesting things in the innovation here of things called mobile fire teams. There's a unit that's actually up in the north of Kyiv, called the Witches of Dacha, which is an entire female unit who have basically built something called a mobile fire team to where they are able to take out in short range the slow-moving drones that are coming after them. And I talk about innovation and technology. One of the innovations that have come about have been something General Hecker, the USAFE, the United States Air Force's Europe commander, has talked about on a non-infrequent basis. But it is their air fence system, of which they were able to utilize existing cellular networks and existing cell phones in order to provide acoustic tracking, because of the uniqueness of the sound of the ISR drones that are coming attacking them, and combine it and provide early warning through to the AOCs, to the air operations centers that are able to then track and be able to provide information to these mobile fire teams, to air defense networks in order to shoot down and be able to help defend. With that, Ukraine still cannot attack into Russia with the capacity that would allow them to be able to push the air attacks even further back. With that as well, because Ukraine is a 24/7 business, they've had to come up with those creative solutions, but it is still absorbing energy from the nation. One of the centers of gravity is going to be the population, the energy sector. Those are all very high concerns in Ukraine, and this persistent and pernicious attack that continues over and over and over again because of lacking that generalized air superiority, they are going to continue to need to have their quivers filled of air defense missiles and to be able to continue to try to put pressure on the Russian air attacks they're going through. Now, I do want to talk about the other part of attacks on sovereignty, and the other parts of the air war that don't get as much attention. But if you'll see these things called UMPKs, what the Russians have innovated as is they know that they need to bring more firepower to bear, and they are going to have to start hitting second echelon. So they're going to have to hit areas that are within that sort of 20 kilometers to 100 kilometers into Ukraine. And so what they've been doing is they've been having a challenge of being able to bring their ballistic missile socks are reserved for more precision targets. They want to be able to preserve some of that. And so in order to increase the range of a large number, a ubiquitous amount of dumb bombs, of gravity bombs, the Russians have been able to take and put basic glide kits onto their dumb bombs with a basic GNSS receiver in order to increase the range at which they can launch their air-delivered munitions from within sanctuary areas in Russia to be able to avoid the air defenses that are in Ukraine and can continue to push them back. Those have been a particularly vexing and a particularly violent challenge because while they talk about them being somewhat precision, they're really just very much longer range. And you've seen in that ubiquitous information environment, the utilization of UMPKs to go after cities and to go after civilian population centers as part of that cog. In addition to that, that's also raining down upon the defenders in the first echelon and second echelon of defenses. With that, the Black Sea corridors, so remove going to things that aren't actually shown on the slide, but again, considered part of the fight that the Ukrainians have been innovating in. Without having an established and large navy to be able to combat the Russian onslaught along the Black Sea channels, the Ukrainians have started amplifying their utilization of things called USVs, uncrewed surface vessels, and UUVs, uncrewed undersea vessels, and have been innovating. They're very sensitive about this particular side, and I'm sure that's something which, again, they wouldn't want to have broadcast in terms of the tech, but the bottom line is they have been using those to good effects in order to provide, again, more problems for the Russians to try to deal with, and they've been able to sustain the ability to open the Black Sea corridors that are associated with the attacks on sovereignty. The asymmetry between the resources Ukraine has to bear against the Russian onslaught in the air and maritime domains has been typified by a lot of creativity, a lot of technical solutions that bring together surveillance, unique solutions for air defense, and an energy that won't be untapped, but is impressive to watch. And finally, the Kursk offensive, which I found a lot of us were surprised with what they were able to pull off, and the fact that they're sustaining position in the Kursk region is actually quite impressive. As we started to unpack how they were able to do this, first and foremost, they utilized the information environment in order to distract everybody, Russians, allies, coalition, to not really think that this was even possible. In addition to that, they knew that these were areas that were reasonably open and did not have the kind of forces that they faced in the south. And so as they attacked forward, the advantages they made were incredible. And they were actually able to utilize uncrewed systems, and they were able to utilize the use of uncrewed systems in order to perform what I would call a joint effects. They were able to find and fix Russian forces. The Russian forces had not arrayed some of the electronic warfare systems that were denying them capability in the south, so they were able to use clear video to be able to go after and to be able to attack and stave off counterattacks in this region. And so this part of the offensive has been absolutely fascinating to watch. And again, the 3 U's apply with respect to how they're employing them in order to maintain the footholds that they have. I will say one of the things that they did was they actually, to good effects, they utilized air-delivered munitions to be able to actually cut off Russian forces along the Sime River, which is right here, from being able to, so they could actually hold the territory that they have. Now, in the geopolitical realm, we'll find out just how effective that offensive was or is going to be. But the bottom line is it is starting to spread Russian forces even more thin across the entire. All right. So let's talk a little bit right now about what we all sort of like are gravitating to. So uncrewed systems on air, land, and sea. You can break down a framework for me to be able to talk about this in the fact of individual kinetic strike, intelligence, surveillance, and reconnaissance operations, and lethal and non-lethal delivery capabilities. Underneath the individual kinetic strike, everybody, we've seen the videos. I've got a few exemplars of them, of the first-person viewer, short-range uncrewed systems that are in mass along the front. They are utilized for short-range surveillance, but more importantly, take some C4, take some explosive device, and have an operator drive these first-person viewer drones into aggressor activities. Now, at the same time that's happening, the Russians are using the same sort of tactics. So there is a drone-on-drone war going here. First-person viewer drones typically utilized in that first echelon and to go after each other. More lethal are some of the loitering munitions. And this is where you start combining some of the ability for a bigger system. So high group 1, group 2 type size that will have a particular geographic area that will orbit, and then some level of automatic target recognition that they're able to utilize in the EO, IR sensors that they have on that in order to identify key targets that they can fire lethal munitions on in a semi-autonomous fashion. I say semi-autonomous because it is still a very first-person controlled capability. There is still a human being in that loop, although the autonomy of the loitering munitions is going to be starting to see where the future is going to portend, which is these loitering capabilities that have persistence over a battlefield, and they're going to be able to look at a particular set of pre-programmed targets or potentially AI-driven, machine-learned targets that then they can just simply attack utilizing lighter munitions that go after things. Both sides, Russians and Ukrainians, are using these. The Russians have been using them to good effect on the battlefield. The Ukrainians are starting to be able to use them with good effect on that. And then as far as individual kinetic strike, we have long-range strike. This is what we talk about when we got the LROWA, long-range one-way attack drones. Yes, another acronym. I'm very good at using them. I love it. I'm an electronic warfare officer, and I was also a crew capability guy. Counter RCIED, electronic warfare officer. Yes, acronym within an acronym, and continue to be acronyms within acronyms. All right, I digress. Going to the ISR operations. This is probably the one we're most familiar with because this is the one that shows up in that information environment that we are watching on a daily basis, that you see popped up on X, formerly Twitter, you see it up on Telegram channels, and this is the juice that feeds a lot of the hyperbole that has become reality in this battlefield. Because we're constantly bombarded and we're constantly seeing the kind of visual sensing that does this. The technology that goes into each of these, and I've got 3 things listed here. We've got short range sensing, I got tactical fixed wing, I got strategic fixed wing. What I mean by those is the short range sensing tends to be large quadcopter, octocopter type drones that will raise up, they will fly against a particular formation, a trench line, a tree line. They will observe it. They will be connected to a human being that will sit there and make sure that they are watching what is happening on that battlefield. That information will then be fed to targeting cells, or they'll be fed to someplace else at a brigade or potentially maybe a 1-star or 2-star level command, at which point in time those targets will be serviced as necessary, using antiseptic language again on that. Benefits of having those short-range sensing systems is that they can be controlled very closely. You can do a lot of compartmentalization. You can do a lot of dynamic changing of the kind of sensors that you throw in there. At disadvantage, you have to be shorter range. You have to be closer to the front. You could potentially be exposed. Tactical fixed wing are your Group 1, Group 2 fixed wing drones. The advantages of them is they can fly higher, they can loiter longer, and they can generally have repeaters, which allow them to be able to get information back and forth when you're in something of a jamming environment. And again, they can be held at those lower echelons. Strategic fixed wing are larger. Group 3, Group 4, there is no Group 4 really flying from the Ukrainian side to Russians. They really wouldn't have what I would call a Group 4 drone. Really, Group 3 is kind of where their strategic level drones are. They would consider things like an MQ-9, something that's near and dear to my heart, as a strategic fixed wing drone to be able to go after there. That gives you a much broader picture, larger payloads, longer ranges, and the ability to feed back to joint and to larger echelons in order to bring strategic effects to bear. And then finally, delivery. I'm going to call lethal and non-lethal. You've got bomber drones. We have the opportunity. Again, these are devices that, frankly, are again some of the ones that you will see that scare a lot of folks because they are reasonably large octocopters that will then go and deliver small grenade level of munitions to anti-tank mine and larger munitions. They tend to be octocopters, and they tend to be those bigger ones. On the non-lethal side, and this goes through all of some ground systems and some surface systems that will deliver critical supplies, and we'll do that, and that's what's being used in there. So there's the roles and missions. That's a kind of a facile overview of the kind of things. There's a lot of nuances that can be brought in to bear with it, but at the end of the day, that does a good framework for us to talk about what is available and how we can get after it. Because the thing that and as I had a discussion earlier tonight with some of the folks around the dinner table, the idea is that the technology is great, but you have to have an application for it, and that's where I live. And so that's why you have me zeroing in on a lot of the use cases that are exemplars of using this tech to go that. So with that, I want to frame the systems requirements in 7 categories that I can articulate here. Cost. Now I mentioned on the slide inverse to capacity and function. If it's a small drone that has a very limited set of missions and you need a large amount of mass with the large number of drones that are available, you're going to want to drive that cost down. If it is a uncrewed system that will have strategic impact or has to carry large munitions or has to survive in an austere environment, your cost will increase. And you have to start looking at the function that it has to serve. And you have to say, is it worth it for me to be able to pay to buy this cost of drone for what it is going to either protect or whether or not what is going to come after it to destroy it? The corollary is I can take a $10,000 drone, fly it against $1 million missile, and that cost imposition that you're making on the adversary that has to spend that $1 million missile in order to take out that $10,000 drone loses that particular battle. The one condition that I have to make sure that we advise you on that, though, is if that drone is going after a nuclear power plant, maybe it's worth it for you to use that $1 million missile to take it out. So that's a calculation that, again, as we're designing and as we're looking to drive the innovation space, what cost metric do we need to establish and set for us to buy these types of uncrewed systems? Range. I'm going to talk about it being mission-centric. And again, the range will ultimately drive the size. It'll drive the propulsion mechanism. It'll drive the capabilities that you're trying to get after. And again, this being a system requirement that has to be evaluated against what you're trying to accomplish in the space. If what you're trying to accomplish is the ability to offset firepower in a short-range fight, so being able to counter the 10-to-1 advantage that Russians have in artillery fires against the Ukrainians, if you want to offset that advantage, you're probably going to want to have a large number of smaller drones that you're going to be able to put a small explosive package on in order to provide precision effects against that adversary. So that's going to drive your ability to have that short range system that's going to go there. Now, related to range, you have endurance. Again, endurance comes down to what your mission is actually going to be accomplishing. Now, isn't range and endurance the same thing? In some cases, I guess you could call it that. However, when you're talking about being able to derive and build the requirements for these types of systems, if you want a loitering system, you're going to want to have a very efficient motor. You're going to want to have a very efficient propulsion system. You're going to want to have a very resilient C2 system so that you can continue to connect to that particular drone. And so if it's a 6-7 hour endurance that you want to be able to utilize this, that's going to drive the mission cost. That's going to have that, and it's going to have effects across the board on the other pieces. I come back to something that's near and dear to my heart, and I will give a shout out to a colleague of mine, Colonel Dave Blair, who has started looking extensively at the idea of affordable mass and attritable systems. We have a healthy debate that goes on to, is it better for you to have a large number of very cheap systems or a small number of very survivable systems? A facile argument that I've heard articulated in the past has been, well, I want a lot of cheap systems so that I can mass produce them and I can throw them at the adversary. Cool. We can do that. That's exactly right. But you have to think about what you're actually trying to accomplish with that. In the case of a long-range one-way attack, perhaps if you don't have the means or the resources in order to build a truly survivable singular system, then the cost imposition that you can have on the adversary to be able to mass forces against them drive that attritability. And I will argue that at some point in time, I'll write a paper and maybe I'll come back and talk to you about this if you ever invite me back, about an attritability index that you can apply to an acquisition system. So an attritability index of 0.1 means that, one out of the 10 systems that you buy has to make it through to actually accomplish its mission. An attritability index of 1 means that system has to survive in an austere environment for a long period of time to go after that. Consider payload, part of a mission-centric capability. Are you looking for a sensor? Are you looking for an explosive delivery? Are you looking to just deliver something that has to of non-lethal nature to be able to come back and forth? And then, near and dear to my heart is the command and control model with which you want to employ these systems. A couple different key things that are going to be associated with this command and control system. You're going to have a command link, because we are still airmen, soldiers, sailors, Marines. We are still people that want to be able to control the killer robot that is sitting in the air. Now, I don't mind if my Roomba goes ahead and autonomously maps out my entire floor and does what it needs to do, but that Roomba better stop when I give it a command to say to stop. So the command link is very important. Command link is something which allows us to stay connected. It keeps that uncrewed system to be crewed from a remote section. However, that presents vulnerability. It has to be over an electromagnetic wave. It has to be over that, or potentially over a network, but associated with the electromagnetic spectrum is there. Now I break that out from downlink. The downlink is the information coming off of the drone. You have to be able to, if you are designing the capability of the system in order to be a sensor, the sensing does know, it can do good for you if you have a recording system and you have a recovery plan in place for it. However, that isn't practical in a lot of situations to which the dynamic situation of the battlefield is changing as rapidly as it is. Resilient GNSS, Global Navigation Satellite System. So we have found one of the best ways for us to be able to determine our position. Well, again, I grew up an electronic warfare officer, which actually goes through navigator school. So the fact is that I can tell you that the best way for you to have a position is to have a human being that's actually telling you exactly where you are, and go for dead reckoning to say, I'm over this place, I'm traveling this fast, and I have this much of a crosswind because of me. I'm going to be here, I'm going to get there. Great. That's all wonderful. However, the beauty of GPS technology, the beauty of GNSS technology has allowed us to be able to determine geometric location down to a science that is, down to a precision that is actually unheard of. There's a problem. If we are reliant upon electromagnetic signals in order to provide us that three-dimensional location, which is necessary, and that goes across the entire spectrum, no pun intended, of uncrewed systems. It's absolutely essential that we know where we're at. And so a resilient GNSS in technology that needs to happen with that. Two things that get overlooked in some of this talk about the ubiquity of uncrewed systems is the launch and recovery model that you're following. This will be driven. This is why the group 1 through 3, those smaller UASs, are really, really attractive. They're really attractive in a fight where you have to, where fixed locations are going to be under threat. The launch and recovery model is something as simple as the soldier holding it up, turning it on, and throwing it in the air, to a catapult system that's associated with a larger system but needs to get you a way to slingshot something in the air, or an actual runway system, which, as you start to get larger and larger, you're going to need in order to develop the lift, and, we can go full Bernoulli and just, take off and get everything moving. And then finally, you need to take into account the ground control system, the ground control station, whether that is a set of Oculus Rift goggles with a controller, or whether that is a computer, or whether that is a notional cockpit, to be able to fly and control this particular system. In addition to that, that gives you the ability to do mission planning. It gives the ability to inject software into the actual system so that it can do the job that it can, or it can evaluate quickly. And then finally, I picked this one. I picked number 7, kind of in as a lark, as the last sort of thought on it, which is the remote versus autonomous control. The reality is most of what's happening on the battlefield today is remote control. We tend to think of, again, very scary killer drones as being these autonomous creatures that are going to go out there, find themselves becoming self-aware at some point in time, realizing we're trying to get them to kill other things and they're going to come back and kill us. Probably not going to happen. 2001 is a long time ago, and it hasn't come to fruition so far. But the bottom line is we are at a place where remoted control has been the model which has been followed in the majority of the systems that are in the battlefield today. The autonomous control piece of it is a place where we are ripe for development and innovation. I can tell you the U.S. Air Force is looking heavily at the autonomous side of things because that frees up the workload for the gray matter computers right here to do the really smart stuff of actually being able to have a strategy to be able to attack and overcome an adversary of which there may be an asymmetric advantage or disadvantage to. All right. Uncrewed systems, air, land, and sea, a roles and mission framework, and a systems requirements framework. So it comes back to, I wish I had a video. I wish I had been able to grab a video that we had seen on that of some of the first-person viewer. I will tell you that now that we're on YouTube, for those of you that are on YouTube, you can look at this particular link. I will give credit to where credit's due. But effectively, the first-person viewer side of things has been I will say, a massive evolution in the manner in which they are delivering capabilities. And again, capacity requirements are in the thousands per day. And really, they don't need them to be used for very long. The components of them are listed there. What the advantage is really that you can precisely strike at a target without having traditional precision munitions in order to go after them. Now, being able to thread the needle with a first-person viewer drone, it's a really difficult task. So this goes to what is at the center of a lot of the stuff that I do on a day-to-day job, which is the organize, train, and equip of a force. The thing that I've been watching the Ukrainians do with an incredible amount of veracity is their ability to learn how to employ first-person viewer, which is a tremendous technology, effectively on the battlefield has evolved rapidly over the last 2 years. Turns out that we really don't have a lot of great models on the U.S. military side for us to be able to provide them that ability to thread the needle using these types of devices. And so you go to look to commercial industry, and you go to look to something as innocuous as drone races. If you've ever seen some of the drone races that are conducted, you can see that they have a significant skill set of being able to apply precision in flying these particular devices. And again, flying a remote asset, you are not reliant upon any of the visceral sensation that that you would in a manned aircraft. And it's probably one of the things it's been hardest for me to come forward with because of the number of aircraft that I've actually had the opportunity to fly. And the idea that I've got this, sort of romantic sense of, the aviator with the, if I had a scarf, I do have a few scarves, and I was going to wear one today, but it wasn't appropriate for this particular uniform. But moving the pride with which you see these operators to be able to fly these particular drones in the virtual sense in a physical reality is equivalent to that World War I aviator jumping into the open cockpit and flying against the Red Baron, for those Snoopy aficionados in the audience. With that, with the preponderance of things that they're using first-person viewer drones for, they need a lot of them. And so with all of these things that are associated with that first-person viewer, cost becomes a key performance parameter that is necessary for you to keep down. Now, obviously, in the first part of the war, DJI drones were big. The Chinese developed DJI drones, which has sort of cornered the market on a lot of that. But as things have developed, we've watched the Ukrainians, we've watched the Russians start to develop local capabilities to either improve or to adjust or to change the nature and capabilities of those particular drones to be able to go forward and be able to use the attack that they have. All right. And play the video that goes forward here. As we start to go bigger, we start to talk about the bomber drones. Now, the exemplar that I'm using here, this particular experiment actually was a use of precision capabilities that were applied to the dropping munitions that was on here. And I'll give a shout out to MIT Lincoln Labs that's been doing a lot of development work on this particular type of thing. But what I wanted to demonstrate in this one and show in this is the difficulty and challenge of trying to eyeball without, if we go back to World War II, without a Norden bomb sight to be able to put it in the pickle barrel, the ability for you to be able to have precision attack with a bomber drone is challenging. And so an innovation that they have been developing has been the ability to use a combination of laser designation and other sorts of precision capabilities in order to go after and actually be able to drop small munitions so that you can knock out that pickle in the pickle barrel that Mr. Norden talked so eloquently about. In terms of ubiquity, they really need to, these again, they are more exquisite systems than the FPVs. They're a little larger, so we don't need as many of them. They tend to persist in the battle space a lot longer, and so we're talking about 300 to 500 a month in terms of what production needs to happen. Endurance, because they're closer to the battlefield, they really only need about 45 minutes, and so that's been the set system requirement that's been identified. And then as far as components, you can see the ones here. Now, in the previous slide, you saw the FPV, launch and recovery. There's really not that much. It's really just a human being throwing it in the air and going for it. With this one, you're going to need something a little bit larger, so you end up with a computer and monitor and a controller station, as well as a transportation cradle. But again, they are octocopters, dodecacopters, however many, rotary ring devices you have for them to be able to apply that. And then the payloads are munitions and equipment and can be utilized across a number of use cases that are necessary and things that we've seen. And again, this is a big one. All right. Near and dear to my heart, ISR, intelligence, surveillance, and reconnaissance drone. The ubiquity, fewer are needed because they persist in the battle space longer. The identified requirement, 50-ish or so a month that need to be developed and delivered. Endurance is up to 4 hours. This is, again, where we end up developing and seeing a whole bunch of the atmosphere, that a bunch of the kind of like images that come out of the information environment. The components, you can see them all right there. Given that the ISR drones this is where you start to work into the fixed wing side of things. Those fixed wing will require some launcher system. The launcher systems can be anything from, again, like I described, the catapult, to something as innovative as sitting on the back of a pickup truck and driving really fast. Yeah. So they have a lot of those, and you can see that the quality of imagery it can be good and it can be poor. I will say that within this one, let me see if I the reason I picked this particular video. Let me see if I can. Perfect. Okay, everybody just okay. I will say everybody see the pixelation on the image here. Well, so the pixelation on the image is actually showing something that is. I was at first I thought it might have just been some of the lag in the actual video downstream that was there, but as I'm starting to look at it in a little bit more detail, the idea is it actually looks a lot like some of the environment that you have as far as electromagnetic spectrum jamming that degrades the quality of the signal that's actually coming off of it. So you can see some of that. In addition to that, you can see the innovations that's actually in the software for how they can go after and start doing auto target tracking and recognition, where you see the individual carriage bubbles actually start popping up, and as you can see here. And again, these are all part of the system itself that would drive into the ATR aspects of it, the ability to look at the pixels that are coming through there to be able to identify based upon a data set that throws into the software camera in order to give you the idea of what you're seeing so that you can reduce the operator workload that's actually looking at this in order to drive the cases back here. And then finally, looking at the long-range one-way attack. When we talk about attritable mass, this is what we're talking about. Building an entire force to be able to bring to bear 100, 200 drones that are going to go after a particular target. They are going to oversaturate an air defense system so that it can't take all of them out. And if even one gets through, you have succeeded. Ranges, everywhere from 100 to 1,000 kilometers. Components, a lot of times they'll add a camera to them, and a camera will be added such that when it feeds back, if there has been navigation updates that need to happen, or if there is an automatic target recognition that goes on there that has to be able to identify to a target. Payload, 50 kilograms plus. A controller, a lot of times. You don't necessarily need a controller, though, so sometimes it's just a fully automated, it's just a pre-programmed flight path, and then a mission planning software suite. And it's something underappreciated, and I can tell you from my perspective of having worked development of things like the ADM 160, miniature air launch decoy, and a number of other systems, one of the most underappreciated pieces of this, and again, me wearing Jupiter's Thunderbolts as a navigator, the amount of mission planning that goes into being able to get an air vehicle from point A to point Z through points B through Y takes a significant amount of time. It takes a significant amount of effort. It is resource intensive from the human being standpoint. As we start to look at developments and technological innovations, one of the things that will help long-range one-way attack become the system that it needs to become will be the ability to do integrated mission planning and mission planning software that is allowing us to be able to bring a number of drones together to be able to coordinate those effects. All right. Run down some of the technical attributes of the various types of systems that are there. So what are some of the challenges that could portend from these? First and foremost, I'm going to go on the physical and fiscal limitations. The physical limitations, your command, control, and cruise. A ground control station with a human being controlling a remote system is what we euphemistically call a juicy target in the auspices of military applications. The establishment of a ground control station, which is going to be a very unique visual signature. There's probably going to be antennas out of it. There's probably going to be that. It could be in a bunker. That is something which we have to be able to contend with as far as how we actually control it. If you're close to the battlefield, you absolutely need to find a place for you to be safe from the strike that is inevitably going to happen because the adversary sees exactly what good comes from that. And as long as we continue to have a very human-centric model for remote and unmanned systems, that human being will still be a central target in everything that we have, even though we are removing this wonderful form of a delicate pink body from the cockpit of the three-dimensional environment of flight that does not get threatened on that end of it. Second, your launch and recovery systems. Again, they have to be, in order for you to launch a system, you have to expose the system and you have to expose the launch and recovery system to the potential for violent attack in the environment, especially with shorter range systems. Even if your command and control system is in a beyond line of sight construct, you're still going to have to get close enough to the battlefield in order to get that particular uncrewed device closer to the battlefield for it to do the job that it has. That is a large signature, and it has the ability to go forward. I'm not seeing the hook yet, but I'm getting close to it. And then finally, cost versus capability. I talked a little bit about this. Attritable must be cheap. If you are intending on using a massive amount of drones, you have to have it be affordable for what you need to do. If you need it to be survivable, it must survive. It seems pretty intuitive, right? Survivable must survive. That is not necessarily something which ends up being intuitive when we spend a lot of money on a weapon system, that we lose out on a particular aspect of a vulnerability that we don't take into account. Which brings me over to the next side of the slide, which talks about electromagnetic warfare. Electromagnetic warfare has proven out to be on this battlefield a game changer when it comes to the ability to control systems, the ability for sensors to see things, the ability for GNSS systems to be able to have precision locations. And it is shown with the ubiquity, I use the U term again, of the amount of jamming that is on the battlefield that prevents the ability to apply these capability requirements, these capabilities as part of this uncrewed system in an effective way. And it has generated a massive action and reaction cycle on the battlefield to where you have the soldiers in the trenches adjusting the frequencies at which they are controlling certain devices because they know that those frequencies are being jammed excessively across the battlefield. You have an insatiable demand for controlled radiation pattern antennas, for SERPA antennas, to be able to find a GNSS signal in an environment that is saturated with electromagnetic interference. You are finding the sensors have to be hardened because of the existence of lasers that can damage or blind CCD devices on the far sides of those sensors to be able to get there. And you have to find innovations in the way that they do command links. The days of being able to have a single frequency where you're talking directly to a single device are long past. We have to find new models, and they've been using, to good effects, various beyond line of sight type models that have been able to do that. And we're going to have to innovate in the automation space to allow for the devices that are there to do the job that they need to do without necessarily the direct human interaction that could be available to them. With that, I get to my reflection slide. On the reflection side, having been woken up every night from early July through the end of September, I will tell you, air superiority still matters. Being able to defend your sovereign airspace is an absolute necessity in modern conflict. Now, that said, at some point in time, air superiority is going to have a challenge when you start talking about 1,000 drones at extremely low level, in which case we're going to have to start thinking about air superiority in a different manner. Like I said, I'll give credit to Colonel Dave Blair on this one, which is the idea of the air littorals, the idea of a zone that is inaccessible by much of the air capabilities that's available to us is going to exist. We're going to have to figure out ways to deal with that. I believe efficient mass over just mass is the best way for us to go. And what I mean by that is we need to be judicious with where we want to apply attritable mass And we are going to want to continue to drive to where we think of mass, not just in numbers of actual platforms, but we look at what effects that we want to bring to bear against an adversary. Commercial technology can flow fast, and it has, but the enemy has a vote. Commercial tech doesn't design for the austere environments that you will find on the battlefield. Now, can you use it? Absolutely. Should we use it? Absolutely. But we need to understand that our systems, our acquisition systems, our defense systems, our military systems need to have a higher level of resiliency if we want them to be able to survive in the austere environments typified by electromagnetic spectrum jamming, physical fire effects against them, and to be able to bring those to bear. Jason Eckberg's observation of uncrewed technology on the battlefield today is we have established an evolution over a revolution. Like I stated, the majority of the uncrewed systems that are on the battlefield today are controlled remotely by an individual operator. There are very few systems out there that are operating with a high level of autonomy that we aspire to. The revolution in uncrewed systems is going to come in the next few years as we build to technology that is going to be able to use autonomy married with human thought and human capabilities in order to deliver effects more effectively and efficiently. War is still war. War is violent conflict perpetrated by two actors against each other or three actors, depending on what level of war you're at, and it still will be a human endeavor. The conflict between Ukraine and Russia is an absolutely existential human endeavor. Real people are dying. Real material is being destroyed. Real visceral environments are being impacted every single day by what's going on there. No amount of automation is going to change the nature of that. And I'm a firm believer that we need to absolutely accept and understand that it is going to continue to be, war will continue to be the inability of humans to be able to reconcile differences in a geopolitical construct that we get through, but it will have to be, we will want to minimize the effects and time in which we do that. And finally, innovating under fire is hard, but it isn't impossible. One of my favorite historical analogies, I've got a lot of them. Mary, don't worry, I'm not going to go much further on this, but is George Kenney in the development of the Commerce Raider in 1942, 1943. He knew he wasn't going to get all of the Gucci stuff that the European theater was going to get, so he took and built out of a bunch of derelict B-25s and what would be considered sort of almost irrelevant aircraft, a thing called the Commerce Raider. It combined the development of tactics, which is skip bombing. It added a aero engineering environment, which he put instead of having self-defense guns, he took those guns and he made them into a forward-firing guns so that he could attack Japanese shipping and Japanese surface combatants, which were going to be the things threatening Australia the most during that conflict. He was able to use these to an incredible effect in March of 1943. It's a great story. It's one which shows innovation under combat conditions that combines the technical aplomb of soldiers, sailors, airmen, Marines with the savvy tactical employment considerations that we're seeing shown on the battlefield of Ukraine today. I have all the respect in the world for the folks that are trying to innovate under fire because it is, again, really difficult. It is a life or death matter. I know that was a little campy. Sorry, but it's something which I've taken to think. All right, my conclusions from a U.S. perspective. Selfishly, I'm thinking about this from a U.S. perspective. I'm going to start with what I think we need to do in the U.S. military is we need to take a look at organizational reform. One of the things about our combat formations is we are absolutely configured for a massive industrial war. Problem is that the massive industrial war is probably not something which is going to gain us eminence in the next time we have to fight. And so with that, we need to integrate into our formations, into our combat formations, the technical savviness, the ability for us to be able to modify effective military capabilities on the fly against an adversary, to be able to react to adversaries that are going to give us challenges and vexing challenges that are there. And we need to be able to do it at scale and on demand. And then as far as one of the popular punching bags is the U.S. defense acquisition reform, I will be a little bit more candid. I'll be a little bit more sanguine in my positivity towards the acquisition system, in the sense that it is designed to do exactly what it is supposed to do, which is reduce as much possible risk for the U.S. taxpayer in terms of delivering a capability on time, on schedule, and on cost. The problem is that it's probably configured for a different time and a different place. And so it hasn't really been able to do either. That said, we need to improve domestic and allied production capability. The sheer volume of kit that has to get wasted on the battlefield will drive us to have to be able to put more into production quicker and faster. We need to design from the start interoperability and extensibility and agility in our combat systems. And then resilience in a combat environment must be the threshold requirement. And resiliency goes from everything from the non-kinetics of electromagnetic spectrum resiliency to being able to survive fire and attack that would be there. With that, I appreciate everybody's patience. I appreciate everybody's time and rapt attention as I've worked my way through the peripatetic path that has brought us to the most exciting moment of the day, which is the question and answer session. Larry, thank you very much for giving me the opportunity.
Thank you very much. And we do have time for some questions and hopefully some answers. So we're going to start with the red microphone. And you may now stand up, tell us your name and ask a question, and tell us if you're a member.
I'm Mark Fraser. I'm visiting from Kirtland Air Force Base in Albuquerque. I was just at the NDIA conference in Norfolk, Virginia this year, where I gave a talk on the use of artificial intelligence to track down hazardous materials in 2 programs in sustainment. Well, one of the major common themes throughout the conference was the use of artificial intelligence in a variety of defense applications. And I was wondering if you had anything to say about that concerning drone warfare.
Absolutely. I can't think of a better thing for me to throw into the slimed environment of nasty bio or chemical weapons or other sorts of nuclear and radiological material than an uncrewed system. I'm sorry, is that the right name for that? Should I have started the question and everything?
No, you're fine. Go ahead.
Awesome. I believe that unmanned systems, and I say that unmanned, unpeopled systems, is absolutely the path we need to follow with respect to being able to put sensor technology closer to something that is going to have a deleterious effect against the actual human body to do that. My first squadron was the 45th Reconnaissance Squadron. We flew opposite the Constant Phoenix aircraft. The Constant Phoenix aircraft obviously goes around the world and looks for nuclear material in clouds, and the amount of preparation that we had to do with the individual crews and the kind of protection mechanisms, life cycle protection mechanisms to be able to do that would be incredible on that. That said, as we've been watching developments across the battlefield occur, one of the things that we are absolutely concerned with is the potential for adversaries to utilize chemical, biological or radiological type capabilities against forces. And with that, to be able to have sensor technology embedded on an uncrewed system that is able to collect, analyze, and in an automated fashion, be able to warn and identify what that material is absolutely an essential requirement for what I think the future of especially Group 1, 2, and 3 smaller UAVs that are able to transit austere environments to where they would have to sense those particular pieces. The bottom line is, I think that's what I think observing what I've been observing on the battlefield here and so on, I can definitely tell you that there is a healthy appetite for being able to get more than just visual and EOIR, electro-optical infrared sensors, or even surface or even synthetic aperture radar sensors. But there is an appetite to be able to put detection systems. In one of my last engagements, as I was leaving, I got the opportunity to work to engage with the Support Forces Command and their Chem Bio division. And one of the things that they were wanting to do is make sure that they had the ability to take and put sensors for that kind of material on drones, because of the fact that it, like telemetry, it allows you to be able to look at that environment, that austere environment, without basically putting at risk the human being that is going to have to collect that particular info.
Did that get your question?
Yes, what about the use of artificial intelligence?
Yeah, he wanted to know about AI.
So the utilization of AI, again, you start to come back to if we can utilize the sensors in order to collect a signature and to be able to autonomously detect that signature, it will provide us the ability to either warn or to notify the whatever command body is necessary in order to react to those particular ones. So as far as I'm definitely supportive of utilizing the AI in that sense. And in fact, I think that's probably a use case that there would be absolutely no questions raised in terms of the moral, ethical capabilities that would bring to bear to be able to assign that to a device. I think it's also one of those pieces where we can train models to look at the various signatures that would come off of, I don't know, unique isotopes, like maybe say yttrium or something like that would actually be out there, or something based upon the previous lecturer's thoughts. But unique radioisotopes that would be able to be delivered and sent. And I think that you could actually train algorithms in order to start looking at not just the things that we have prescripted and that we know that we have a library of, but be able to look at the characteristics of it and utilize a framework in which it can identify, this radionuclide doesn't look exactly like the one that I have in my library, but it looks similar enough to where then I'm going to go ahead and warn with a certain amount of veracity that this is something, or I'm going to collect it based upon the fact that this is a potential for that. And so automated intelligence, this kind of gives me down a theme of path that I have that's been one of my a hill that I want to die on, which is the idea that we have to get away from library-based techniques in the way that we sense austere environments or the way that we sense capabilities. What I mean by that is that that if we continue to leverage only the library that we have of knowns, then we are going to automatically discount probably a huge number of effects that we again are going to discard as ambiguous and not relevant to a particular sensing mechanism. And I'm speaking specifically in the electromagnetic spectrum realm, which is we need to get ourselves off of the cross that we are on with library-based techniques and move to automated intelligence and models to be able to start looking at the characteristics and deeper characteristics in the current pulse descriptor words that we have available for us in the electromagnetic spectrum environment.
Blue microphone.
Ciprian Ivanov, member. in World War I, initially planes did not engage each other. They had other missions. Eventually, it was strategic for planes to engage each other. You mentioned that drones were ubiquitous now. Have we reached the point that there's drone-on-drone predation and that form of evolution?
Excellent question. Yes. In fact, if for those that are on YouTube right now, if you want to go ahead and say drone attack, drone takes out drone, there are a ample supply of first-person viewer videos of drones going after other drones. Now, the videos that you see there are what I would refer to as as I talked about on my last slide, the remoted asset of it, where you have a user who is controlling the actions of that first-person viewer and is trying to take out loitering munitions or ISR drones that are available to it. Again, you can do a search. There is a whole host of videos that have been posted in the information environment to do it. But yes, we are at a place where we are starting to use drone on drones to do that. Now, we go back to the previous question of automated intelligence. We go back to the point of automation. And I will say that is a ripe place for innovation. Because when it comes to use cases in air-to-air capabilities, if you have a sensor that is able to identify positively a aggressor system, you could potentially have set a automated uncrewed system up to do an orbit and just be waiting for a command to go say, I need you to investigate something, where it investigates a particular track that has been passed to it, and will look to see if it matches a profile. If it's a visual profile, it'll be a set of pixels. If it's an electromagnetic profile, it'll match the electromagnetic signature of that particular thing, and it could potentially go ahead and just attack it that way. So I think you're being perspicacious in the sense that you're thinking ahead of the fact that, yes, there is going to be a day where we are going to find drone-on-drone attacks because they are trying, because of exactly what you talked about, that evolution in World War I, where initially it was just, let's observe the battlefield. Well, then adversaries started looking at it and saying, once I heard that thing above me, I started getting 155 millimeter. I started getting French 75s against me. He's probably passing information to him. Let's send up pursuit aviation to go take him out and to do that. And hence the story of air superiority has developed, and this is where we're going. I do know the Ukrainians are starting to work into their mix, the ability to start using, again, mass on mass, be able to bring cheaper vehicles in order to go after things like Shaheeds in particular as well. So
Let's take a couple of questions from the web, and then we'll go to the web microphone. But first, we're going to take from the web.
Hello, thank you very much for your talk. Our first question from the web comes from Mina Feldman from Ontario, Canada. What is the intensity and fragility of the mutual jamming reciprocity and capacity?
can you say the question one more time?
I think I would ask it, what is the intensity and fragility of the mutual jamming going on in the theaters?
Okay. I think I can figure out how to answer this. I will tell you that the action-reaction cycle of electromagnetic spectrum jamming is on a cycle that is faster than what we have seen in the past. I will say that the amount of electromagnetic interference on the battlefield is such that it blots out entire sections of the spectrum, and there are places where there just isn't going to be availability of the spectrum to be able to execute activities. Now, the fragility comes back to my comment about commercial technology is great. It's ubiquitous, it's available, it's there. However, commercial technology was not made in the sense that something was going to proactively attack it to try to deny the link that is available to it. And so the utilization, and I think this is where after the realization of almost 2 years of combat with this, that folks are coming to the conclusion of that says we need to have resilient command and control links. We need to have resilient GNSS links because the current capabilities that the commercial industry has provided is insufficient because of its fragility and vulnerability to electromagnetic interference, which is ubiquitous on the battlefield.
Next question.
Thank you. Next question comes from Joel Wilson, who is a member from Columbia, Maryland. Does the notion of air littorals force a rethinking of the air-land battle doctrine?
I believe that we have, yes. I will say yes. I believe that the air littorals concept starts us to think, has to get us to think a little bit differently about how we will engage in a joint fight against an adversary in the environment where you have the constant battlefield surveillance at that lower echelon command level. And I think where it's going to have us start, where it is going to drive us in the air-land battle and air-land-sea battle doctrine is going to be in concepts that the United States Air Force, the United States Army, United States Navy have come to embrace, which is the concept of mission command at the lowest possible echelon. Knowing that you're going to have a battlefield which is rife with small UAVs, small UASs, and so on, and your ability as a auspicious and vaunted colonel who is supposed to be in charge of the entirety of his or her forces, the fact remains we're going to have to rely upon lower echelon, squad level, platoon level, squad level, flight level organizations in order to act in concert with a joint doctrine that is relevant to the fight that we are going to find ourselves in. And again, I think the advent of those air littorals is going to require us to kind of rethink how we do surface deconfliction and low altitude air deconfliction, as well as how do we bring to bear effects that could potentially mitigate that massive set of capabilities in the air littorals. It's a great question because it's also one that drives what is near and dear to my heart, which is the joint doctrine development cycle, which allows us to be able to evaluate changes in the military environment, changes in the operational environment, and figure out if there's things that we have to do differently in tactics, technology, materiel, policy, logistics, facilities, et cetera, to be able to figure out how we get after that. And so I've been excited to be a part of the conversations that are going on as far as how do we evolve our joint doctrine in order to get after what I believe he was talking about.
Let's go to the red microphone. That's you, Tim.
Timothy Thomas. I am a member of the Society. Thank you for the very interesting and timely discussion. I was reading my Telegraph feed a little bit ago, 3 or 4 days, and the drone operator in Kursk says that he has retrofitted 4 of the FPP drones with AI technology, but it only allowed him to, he had to specify the target. The drone could not select its own target. He wanted that capability. When that capability is introduced to the battlefield, which it surely is being introduced now, how are we going to protect our own troops from these AI-driven killer drones?
How do we counter the counter that we have to go in? Well, first thing we do is we determine what algorithm is being utilized, what learning set is going to be utilized by our adversary would be. So the way I would approach this would be, I would break it down to say, how would we approach the problem of utilizing automated target recognition, AI, with drone detection to be able to go after that? As that gets upgraded, then I would want to look at what are going to be the theoretical cases with respect to how the actual individual targets are going to be met again, think of it from a theoretical perspective. What is in the realm of the possibilities? At that point in time, then you start thinking about it from vulnerability analysis to where now we start talking about, well, what can we do to mitigate that? Can we do something passive? Can we add a camouflaged net or a camouflage pattern that will obfuscate the ability of the AI that is trying to determine a human figure or a material figure that looks at that and obfuscate that. Similar to the way that in World War II that they ended up painting, painting ships in unique ways in order to break up the patterns so that visual recognition was almost impossible from ranges. So that's one place that I would look at it. Active defense. How would we protect ourselves from our own drones? Well, that would be, I would say it's a trivial task of ensuring that you have an identification friend or foe construct. So something that allows the drone to effectively be able to say, oh, that's a friendly, because you have either an active source or you have a visual source that it will look at and say, nope, that's one of mine. And it goes back to sometimes the simplest solutions are the easiest. Simply tanks painting a big, A on the top of it that says, "Yep, this is a U.S. tank." That way, it doesn't get plinked. Is probably one of the simplest solutions that you could have with it. The more complex solutions ends up being either an electromagnetic solution or something that gives you a beacon that says, "I'm a friendly, don't shoot me." That's right. No, it's a great question because it's relevant to the timeline.
AC Trinia member. About 2 days ago, it's a very interesting Wall Street Journal article on Shield AI, and in the open source indicated that the Ukrainians are losing 10,000 drones a month. They have more than 200 drone manufacturers, and the difficulty of U.S. drone manufacturers to penetrate that market. But Shield AI was used as an example as one that has been successful recently. Why are U.S. manufacturers not successful in providing assets in this conflict? Is it because Ukrainians have an asymmetric cost advantage for Type 1, Type 2 systems versus U.S. manufacturers? So what would you say to U.S. manufacturers to provide more capabilities in this environment, would you say?
So I hate to say it this way because it's going to make me sound like I'm dodging the question, but there's a lot of policy implications to U.S. manufacturers being able to deliver specifically to Ukrainian and to be able to collaborate effectively with Ukrainian industry in order to be able to develop, again, to refresh the coffers of necessity that go with the large number of drones that are in demand. Again, it's a policy question, and it's one which, me in the position that I am, it's probably inappropriate for me to discuss in detail sort of the limitations that we have on that. That said, what I would say to U.S. companies that have a desire to work with Ukrainian companies in order to scale appropriately, I will say do not give up in the policy as we go through the policy machinations in order to ensure that the money will go to the development of those Ukrainian drones, to make sure that we collaborate effectively on the ability to get technology infused to the Ukrainian environment. And I will say, do not give up, and understand that there are a lot of engines in the U.S. government that are working diligently to try to ensure that can happen in a responsible and effective fashion. And so, to the companies, don't give up. Keep pressing to try to work with Ukrainian companies in order to scale appropriately. From myself, I will say we will continue to work on the U.S. side of things in order to ensure that policy barriers are pulled and that it is in the most responsible fashion in accordance with national security policy as we implement it.
I think the last question comes from the web.
Last question from Michael Haken, a PSW member from Silver Spring, Maryland. Are directed energy weapons such as lasers on drones a future possibility, considering constraints imposed such as carrying power sources or the tactical utility you'd gain from it?
From a policy perspective, yeah, I mean, there's still a lot of trepidation that talks about the ability to utilize what can you use to be able to use a laser beam on the field and do that. So there still is probably a lot of questions on that one. That said, probably not really that salient of a argument for Russian or even Ukrainian operators. I would say that as we had a conversation earlier about laser technology and so on, I would say that at this point in time, I think the tech is still not there with respect to being able to utilize laser as a weapon on a drone to be able to affect a physical destruction just based upon the swap requirements for a laser system, for a lethal or a destructive laser system. Would probably defer to some of the experts in the room a little bit more on sort of, again, where the state of tech is. But I would say that your biggest limitations with respect to the drone systems that are in space right now is the fact that they would not have swap for what I'm tracking as being the most the size, weight, and power that would be necessary in order to drive the energy that would give you a lethal or destructive effect from a laser. That said, absolutely looking at the idea of utilizing lasers as designators and targeting capabilities in order to increase precision of munitions from those pieces.
Thank you.
Well, thank you very much, Jason, for a very nice talk. We have a few gifts for you before you go.
Yes, sir.
We have a framed copy of the announcement of your talk. We have a ribbon that you can wear on your lapel or elsewhere, which has on its sides the coil of schematic for inductance, which was studied by our founder, Joseph Henry, and the unit of which is the Henry. Oh. And a framed copy of Volume 1 of the Bulletin of the Philosophical Society of Washington, fondly known as PSW Science, in which you'll find the reasons they called it the Philosophical Society, who the founders were, why they founded the organization, and some commentary on how discourse in a scientific organization should be conducted. And with that, thank you so much.
Thank you, sir.
For a great talk and for spending time with us.
Thank you very much for the honor. I appreciate it.
And before you go, very few announcements to be made. 2505th meeting will be on November 22. The speaker will be Jun Yi. Jun is a JLA and UCB fellow and a professor of physics at University of Colorado Boulder. He's one of Catherine Gebbe's recruits at NIST, where he's been working on clocks. He will be speaking on recent results developing the most accurate time clock ever, based on nuclear rather than atomic vibrations, and its promise to open up new experimental studies of basic physics and the development of new, more accurate technologies for communication and navigation systems, among others. The 2506th meeting will be on December 6th. The speaker will be Joanne Hewitt. Joanne is a recently appointed director of the Brookhaven National Laboratory and chair of the Particle Physics Decadal Survey, and she'll be speaking on the state of and priorities for the future of U.S. particle physics, focusing in particular on colliders. The 2507th meeting will be on December 20th. Speaker TBD. Not an aside, but worth mentioning, on February 7th, Nick Lane, professor of evolutionary biology at University College London, will be coming from London to speak on his theories of the origin of life. And Joanna Drucker, professor in the Department of Information Sciences at UCLA, will be speaking about the origin and development of alphabets on March 7th. Other meetings are currently being scheduled, and we will post commitments to the website as soon as they are set. So please check the PSW website frequently for updates to the schedule, www.pswscience.org. Let's thank all of our helpers for helping with tonight's meeting. Thank you, helpers. One last item. Don't leave without returning your name badge to the plastic bin in the back that says, "Place name badges here." And with that, I will take a motion to amend the meeting. To adjourn the meeting. We have a motion, a second. All members in favor of adjournment? All members opposed? Meeting is adjourned.